I'm Madhavi. I'm working as a professor in K.S.Rangasamy College of Technology in the Department Computer Science and Engineering. Today we are going to discuss about list ADT in data structures. So how we are going to organize the list? With the help of array implementation we can organize, and then we can with the help of linked list implementation, with the help of cursor implementation we can organize the list. So with the basic implementation we follow the array implementation. In the array the elements that are stored in continuous memory location. When we are doing addition and deletion operation, it takes a very large amount of time to process the data because so it is a static one. So if we remove the element, if we delete the element from the list, that position it is a vacant position. Suppose we want to reuse the position, so we have to traverse the entire list in up one position. So that's why that is a disadvantages of array implementation. So that's why we go for the linked list implementation. So in a linked list implementation, the elements that is not stored in a continuous memory location, with the help of the address we can find out the next element. So the linked list with the help of the pointer we can implement. Basically the linked list, it is a collection or series of structure. So each structure it holds two parts, one is data, another one is address of the next element. Address of the next element. So here this is a node, the A1, the data part, and then the next part it holds the address of the next element. With the help of this we can point out the next element and the next element. Okay. If it is the last element in the list, means the next part it contains a null value. So this is a actual list. So the 800 it is address of the second element, the 712 it is address of the third one, 992 it is address of the fourth one, 692 it is address of the fifth one. In the fifth, you see the next part it contains the value 0. So because it indicates the end of the list. So how we connect the first element of the first node in the list? So with the help of the header node we can connect. The header node it stores only the address of the first node. So that's why it is called as a dummy node. So for the deletion operation, that is as usual we can done several operations, insert, delete, search, display, all the operations it is possible in a linked list. For the deletion operation, simply we can we do one pointer change. That is, if you want to delete the A3 node A3, so we want to store the address of the fourth node in the second node's address. So then we can connect the second node and then fourth node. So with the help of the free function we can remove the node 3. Then so this is a insertion into a linked list. So for that we want to insert an element in between second and then third node. So this node it is initially, so we have to allocate a memory initially. With the help of the malloc function we are allocating the memory space. So and then we assign a value for that. So how we can assign a memory with the help of the address, assignment of the address, it can get a link in the actual list. So that is the address of the temporary cell, it is stored in the next part of the second node, and then address of the third node it is stored in the temporary node. Then it is get connected, it represents the actual list. So this is the advantages of the linked list. When we compare to the array implementation, it is static, it does not grow and then shrink. But the linked list it is a dynamic data structure. So it can grow and then shrink during the execution of the program. So it have a effective memory utilization. So whenever the memory is, whenever we want to insert an element into the list, so we can allocate. Whenever we remove the element, it is free from the, with the help of the free function, we can reuse the memory, and then the element it is deleted from the list. So and then the insertion and deletion it is easier. and then it is efficient in the linked list when we compare to array implementation. So with the help of the linked list, many complex operation can be carried out. So when we consider the linked list, it have a variety of linked list, that is singly linked list, doubly linked list, and then circular linked list. In a singly linked list, it have only the two part, that is data part and then address part. With the help of the header, it connected the first node and then the address of in this way it get connected. When we consider the doubly linked list, it holds three part. So one is address of the previous node, another one is data, and then address of the forwarding node. That is, it holds the successor and predecessor node's address. So we can traverse in the doubly linked list, we can traverse in both direction, forward and then backward. So and then in a circular linked list, that is the first node it is connected with the last one, the last node it is connected with the first one, because that is the last node it holds the address of the first node. So that's why it is called as a circular linked list. So in the circular linked list, it is an efficient one. We need not to have a header node here. So because the last node it contains the address of the first node. Thank you.